What's good, everybody? Welcome to a video on the biochemistry of calcium homeostasis. And so calcium has a variety of very important functions in the body, such as bone health, muscle contractions, action potentials and nerves, clotting, and acting as a second messenger. And in particular, muscle contractions and action potentials and nerves have been covered in pretty explicit detail in other videos on my channel if you want to check them out. Overall, calcium regulation is primarily mediated via parathyroid hormone with help from vitamin D, as well as calcium, magnesium, and phosphate, all having different interactions with vitamin D and PTH. Parathyroid hormone's main job is just to increase serum calcium when it's too low. And your parathyroid glands are found on the back of your thyroid. So you can see a normal thyroid on the front of somebody's neck is how this would look. And if you flipped it over, there's 4 tiny little parathyroid glands in the back. This is why, sometimes when people have to have their thyroids removed, they have calcium absorption issues afterwards and have to take a lot of extra calcium and vitamin D. So generally, parathyroid hormone is modulated by the other things we discussed. It's increased with low calcium, also increased by high phosphate, decreased by high vitamin D, and decreased when there's low magnesium. So in particular, PTH is increased by low calcium because, that's its primary job. Is if calcium is too low, and it's obviously needed in a variety of important functions, it helps to release the calcium from the bones into the blood so that it can be used in all those different reactions. Furthermore, it's increased in high phosphate environments because phosphate binds to calcium and inactivates it. Furthermore, high vitamin D decreases parathyroid hormone secretion because it increases absorption of calcium in the intestines. So if you have more calcium in the body, then you don't need PTH to increase the calcium in the blood. Furthermore, PTH is extremely dependent on magnesium to properly function, and magnesium acts as part of the signaling pathway for the calcium sensing receptor. Now, what are the specific effects that parathyroid hormone has in the body? So the 2 places that the parathyroid hormone primarily acts on is the bone and the kidneys. So on the bones, it's able to ultimately create an upregulation of osteoclasts, which are cells that help to break down bone. And it does this by increasing the osteoblast rank L secretion. So in the diagram here, PTH will bind to an osteoblast. It'll go in, upregulate the transcription and ultimate translation of a rank L protein from that osteoblast. That rank L protein will go to the rank receptors on the precursor osteoclast cells, which are actually macrophages. So essentially your white blood cells eventually become osteoclasts, which break down your bone. So once again, the rank L binds to the rank, turns the macrophage into an active osteoclast, and the osteoclast breaks down your bone, releasing a bunch of calcium and phosphates into your blood. Additionally, it decreases OPG secretion from osteoblasts and osteocytes, and this is able to increase the amount of rank L because normally OPG binds to rank L so that it can't bind to the rank. So you can see through increasing the rank L secretion and decreasing the OPG, which decreases the rank L, able to allow more rank L to bind and create more osteoclasts, which then liberate calcium and phosphate to be used in the blood. PTH also affects the kidneys to increase the amount of calcium in the blood. In particular, it inhibits phosphate reabsorption. So as you can see on the side here, you have the tubular fluid, meaning this is the kidneys. You'll have water kind of come through here with all the different things that have been in your body. And then the electrolytes will be kind of sifted through by the tubule cells in the kidneys and determine whether it needs to stay in the kidneys to be excreted in your urine or come back in the body because it still is useful to you. So when PTH comes to bind to this proximal tubule cell, it will inhibit this phosphate and sodium co-transporter so that phosphate and sodium are not able to enter back into the blood to be used. And so obviously if there's less phosphate in the blood. That means there's less phosphate that's able to bind to calcium. So there's more active calcium can be utilized. Additionally, PTH is able to increase the amount of calcium in the blood because it increases the transcription of the 1-alpha hydroxylase enzyme. And this is the enzyme that converts 25-hydroxy vitamin D3 into calcitriol, which is the active form of vitamin D. And so this active form of vitamin D goes on to bind in your intestines and increase the amount of calcium in your blood. Finally, the last way that PTH increases calcium in the kidneys is it binds to the distal tubules and just directly increases calcium reabsorption. So once again, you have some urine traveling through your kidneys. There's some extra calcium in it, and it activates a calcium channel to uptake it through the distal tubule cell and back into the blood to increase your serum calcium. And this is just a diagram showing the various forms of vitamin D3. So as we discussed before, the 1-alpha hydroxylase enzyme is the enzyme that's upregulated by parathyroid hormone in the kidneys, takes 25-hydroxy vitamin D3 into calcitriol, the active form. And then the rest of this just kind of shows the general pathway. So the other way you get vitamin D is when UVB rays hit your skin. They release a 7-dehydrocholesterol molecule, which becomes vitamin D3 that you can get through food intake. And then that's catalyzed into the 25-hydroxy vitamin D3, which is used essentially as storage until it can be transformed into its active form. I hope this was informative, and have a good rest of your day.